taking a long time to load it though. Put your questions on here, the 1-4-24, right?
Yeah. Some of them are like a little blurry, but
Jamboard's going away, and they're probably not servicing it right now, keeping it up to.
yeah, I saw that when I opened the app. I was like, oh, Mr. Giant's not going to be happy.
Yeah, I know. I see it every time I open it. It's sad. I still haven't. I'll have to do it this summer. I'll have to try to find some alternative.
Yeah.
But right now, there we go. All right. Number 6.
Yeah.
Okay, so it says Roberto is being dealt a 5-card hand from a standard deck. What's the probability you'll get it?
You're not sharing your screen right now.
You're right. I'm so sorry. Thank you for that. Yeah, the Zoom interface has changed a little bit too, so it's throwing me off a little. All right, can you see it now?
Yeah.
Okay, Roberto is dealing a 5-card hand from the standard deck. What's probably he'll get at least one ace. Yeah, so the best way to do this, at least one ace, you first find out the probability of getting no aces. And then you take the complement of that. In other words, you subtract it from 1, because those two things add up to 100%. Does that make sense?
Yeah.
So you find out what the probability is he'll get one ace from a standard deck. So he's being dealt a 5-card hand. So the first card that he gets, the probability of getting an ace. Did you write this?
Yeah, it's not correct. I know
that it's the right idea, but you're doing it the opposite way. So what's the chance he'll get an ace from the first card, from the first of the 5 cards?
Isn't it 4 out of 52?
Yeah, it's 4 out of 52. And then the probability that he'll get an ace. Let's see. On the next hand, there's a chance. Let's see. Shoot, is that the right way to do this? No, I'm looking at your problem and I'm thinking that might not be the right way to do this. Because the next card, there's 51 cards left, but you don't know how many aces there are left. Because you don't know if he got an ace. So I think what you want to do is at least one ace. I got to think about this for a second. Let's go on to another one first, okay?
Okay.
And let's come back to this because now my head is thinking of doing it a certain way with the method that you're using here, but I just don't know that that's right, because I'm trying to think through. Four out of 52 is the probability of getting picking one ace. Probability. Oh, wait, hold on. Oh, so sorry. Hold on. No, that actually might be right. Okay. So what's the probability of getting no aces? Okay. What's the probability that he gets no aces? Actually, this is maybe correct, because the probability that he will get no ace, you have to pick. There's 48 cards that are not aces to choose from. So that's the first one. And then there's 47 non-aces left. And there's 51 cards to choose from. And then there's 46. So actually, this is correct.
Oh.
That is the right way to do it.
Wait, so why does the 48 go down to 47?
So what you're doing is you're saying, how many cards do I have that are not aces? There's 48 cards that are not aces.
Yeah.
And so you have to pick one of those 48. And there's out of 52, there's 52 total cards to choose from. And you have to pick one of those 48. Then to pick your next card, so that's your first card that you're picking, right? Then to pick your next card, you already picked one of the non-aces, so there's only 47 non-aces left out of a total of 51 cards left. So now you got to choose one of those 47 cards. Then there's 46 cards left that are not aces and only 50 cards left. Then there's 45. And so each one of those is going down by one.
Okay, that makes sense.
Yeah, and then you can cancel things out. That 48 will cancel with that 48. And you can you can just punch in your calculator if you want and figure it out. But yeah, that's right. Do you have the answers for this?
Well, I think the answers that are on my paper are the actual answers.
So that probably is the correct answer.
Oh, okay. Well, I just circled it because it was confusing. So
Yeah. So that, I don't know if you probably don't have a hard time punching in your calculator, right? Good with that. Do you want me to go over another one of those or on to page 2?
No, that makes sense. I just I think it just had to be explained out and then it made sense.
Yeah. I was, for some reason, I was thinking that you needed to pick aces, but you don't actually want to pick aces.
Yeah. I think it was just knowing that when you pick a card that you're picking one that's not an ace, so that reduces.
Right. That's right. But you already picked one of them, so there's only 47 left, right? And out of 51 cards. So that's why each is reducing by one each time. Page 2, it says a hat contains tickets marked 1, 2 to N. A ticket is drawn from the hat. Then without the first ticket being replaced, the second ticket is drawn. What's the probability? The first ticket drawn is the number 1 and the second ticket drawn is the number 3. So you have N total choices and you want the first one to be 1. So there's one way to do that. 1 out of N, whatever N is. And then now there's one less because you didn't replace it, right? There's one less ticket. So there's N minus 1 choices left over. So now you want to pick the number 3 and there's only one of those, right? So 1 over N times 1 over N minus 1 is the correct answer, which simplifies to that.
Okay.
That makes sense?
Yeah, I think I just got confused because we never did a problem with a variable instead of an actual number. So I think that messed me up a lot.
Yeah. So all you think about is if this had said 7, just imagine it said 7. Then it would be 1/7 times 1/6.
Yeah.
Right?
Yeah.
So now just take out that number 7 and just think about that as you don't know what the N is, but it doesn't really matter. whatever the n is, it's just your answer is going to be 1 over n squared minus n.
Okay, yeah.
Okay. Next page. Let's find the probability of
On
which
D.
one? D. Okay. Probability that at least one die is 5, given that the sum is at least 10. So you find out where how many of them have the sum of at least 10. That goes in the denominator. It says given that the sum is at least 10. So that goes in your denominator. You ask yourself, how many dice have a sum of at least 10? So count that number up. Sum of at least 10. Count that number up. And then the top is find the probability the die is at least 1. So given, let's see, find the probability that at least one die is 5. Okay, so at least one of these, and by these I mean these, is 5. So let's look up at our choices. How many dice is at least 10? So go to the tens, and I'll just kind of circle the ones that are at least 10. So that's 10, that's 11, that's 12, that's 11, that's 10, and that's 10. Right? Those are the ones that are at least 10. And which of ones of those is at least, it has at least one, let's see, probably that at least one die is 5. So does this have at least one die that's 5?
At least
No.
5? No.
At least one die is the number 5.
Okay, yeah.
So now we're going to cross out the ones that, or actually let's circle the ones that have at least one 5. There's one, and there's one. Got it? So
Yeah.
there's 3 choices, and there's a total of 6 die. So that's 1/2. So the probability, conditional probability, is 1/2.
Oh, okay. I don't think I approached that the best way when I was doing it in class.
Yeah. You want me to do F now? It's a similar one.
I actually got F. I understood F.
And you understood it?
Yeah.
Okay.
But that's like all my questions.
Okay. Still got probably five or so minutes if you want to ask another one. Do you have another problem you're not so sure about?
No, because when I was doing my math homework, I usually circle problems, and this unit I actually pretty understand.
Yeah.
Just a couple of these questions were confusing.
Yep. Okay. Any old tests or anything that you did that you're not so sure about?
Well, we aren't allowed to take our test home, so.
Oh, okay.
Yeah.
Have you been doing okay with it though?
Yeah.
Okay. Are we doing combinations and permutations yet?
No.
You're not doing that yet?
No.
Okay. Are you done with this unit, or are you going to keep doing some more? Is there more probability?
Our next unit, let me look at what it is. Our next unit is give me a sec. Our next unit is sequences and series.
Oh, okay. So you haven't had to do something like this, 5 choose 3, which sometimes is written like 5 over 3 like this. You have never had to do that?
No.
Okay. I'm surprised. That's a huge concept in probability.
Yeah, no, we never learned that.
Okay. Well, yeah, it's okay. Maybe you're just doing more basic stuff, but like if you had 5 options for for a salad, or for a pizza. You could, for toppings of a pizza, your options are bacon, anchovies, sausage, green peppers, and onions. So there's 5 things and you have to choose 3 of them.
Okay.
How many ways can you choose 3 toppings for pizza? You haven't done that yet?
And like, wait, this would be like, you can't, they aren't like, you can't choose like the same topping. Well,
Yeah,
would
you
it be,
can't double up on a topping.
I feel like we have, but we just like never did it like that. We would do like, what would we do? We would do like 5 times 4 times 3 because there's 3.
Yeah, yep, that's it.
Yeah, but we didn't. Yeah, we didn't have like the C or whatever.
Okay, you haven't learned the way, because there's a shortcut way to do that. It's with Pascal's triangle. You haven't learned that yet.
No.
So watch how I'm making this triangle. Do you see what I'm doing?
Yeah, you're adding. Yeah.
Yeah. Yeah. So this is called Pascal's triangle. And so here's the 5 row.
So like, is the end, like the far left and the far right, is that always like what you start with? Like the number on the very.
Yeah, you just start with 1 and then you just add the 2 numbers ahead of it. You start and end with 1. So you add the 2 numbers above it, right? That's what you're doing. See that? Those add there, those add there, those add there, those add there.
Yeah.
So the way that this works, this right here is 5, choose 0. There's one way to choose 0 if you're given 5 options. This is 5, choose 1. There's 5 ways to choose something if you have 5 options. 5 options and you're choosing 1. Like if these are my 5 options, there's 5 ways. 1, 2, 3, 4, and 5. This is 5, choose 2, which is the same as 5, choose 3, by the way, because choosing 2 is like not choosing 3. So I could choose those 2, those 2, those 2, and those 2, or those 2, and those 2, and those 2, or those 2, or those 2, or those 2. I just did 5 different things.
Yeah.
Or sorry, 10 different things, right? So that's Pascal's triangle. So 5, choose 3 is just 10. I know it's 10 if you have if you have Pascal's triangle. And like you just said, you would do 5 times 4. Wait, you said 5 times 4 times 3. No, that's not how that works. It's not 5 times 4 times 3. So what you said is actually not the same thing. 5, choose 3. How many ways can I choose 3 things out of given 5? It's 10. There's 10 ways I can choose 3 things. I can go B-A-G, B-A-S, B-A-O. There's 3. Or I can go B-S-G. Whoops, B-S-G. I'm kind of skipping, right? Or B-S-O. There's 5. So that's all my B's. And now I can do A-S-G or A-S-O or A-G-O. There's all my A's. And then I can do S-G-O. I'm missing one. B-A-G, B-A-S, B-A, B-A-S, B-A-G, B-A-O. Okay, B-S-G, B-S-O, B-G-O. I missed B-G-O. So there's 10 options.
Oh.
Got it? But you haven't done that, huh?
No.
Because there is a formula for that.
Is that like a function on your calculator?
It is.
Oh,
it is
I
a
think my
function
friend
also.
told me that the other day.
Yeah, but I feel like that's a part of what you're doing right now. You seriously haven't done that yet?
Yeah, we've literally never done anything like that.
Wow, that's surprising. Yeah, on your calculator, it's in the math button,
Yeah.
probability. So it's N choose R. So 5 choose 3 is 10.
Oh. Oh, okay, I get it. I get it. So the number at the front is like the amount of options, and then the other number,
Right,
how many that you're choosing out of
right.
those options.
Yep,
Oh, okay.
yep. Now permutations is different. That's when the order matters. So
Oh,
permutations, like now I have to take this and whoops, I take this one and it matters what order I pick them in. So BAG is different than BGA, is different than GAB, is different than, right? So the order matters for permutations. So you're going to have a lot more. So that would be 5 choose 3 if the order matters is 60. And again, I'm just surprised you haven't learned that. That's not been a part of what you've been doing, but that's okay. That's good
yeah, our
because
district is a little different, so
it can get kind of tricky when you're doing
yeah.
that stuff. But I was going to teach the Pascal's triangle to you because a lot of times they don't do it. You just kind of count on your calculator and just punch it in your calculator, which is fine that you use it. But if you already have a Pascal's triangle written out, it's actually really easy to use a Pascal's triangle.
Oh, okay. So like with the triangle, if you kept going, is it just going from 0, 1, 2, 3, 4, 5?
Yep. Yep. So 1, 6, 15, 20, 15, 6, 1. So this is 6. It's always this number 6. Choose 0, 1, 2, 3. That's 6 choose 3. 6 choose 3 is 20. So if I do 6 choose 3 instead of 5 choose 3, I get 20.
Oh, okay.
So Pascal's triangle is just a really nice, it's a really cool little kind of trick you can use to find combinations and permutations. Now, the reason that's so important or so nice, because you're going to do this later as well, is if you're doing something like x plus 2 squared,
Yeah.
this is actually Pascal's triangle as well, because what you do is it's just x squared times 2 to the 0 plus, and it's 2 choose 0, then 2 choose 1 of x to the 1, 2 to the 1, plus 2 choose 2 of x to the 0, 2 to the 2. I know that maybe it seems confusing to you, but you'd think, well, why would you waste your time and do that? Well, the reason is because if I put a number like 5 here,
Yeah.
then that same pattern would work if it was 5 instead of, this is called binomial expansion. And so what you would do is you would put, I'm trying to think if I did that right. These numbers might be not correct, but I think that's what it was. I think it was, so these numbers, you always start with this degree there and 0, and they always add up to 5. So that's 4 x to
Uh,
the 4th and 2 to the 1st and x to the 3rd and 2 to the 2nd plus x to the 2nd and 2 to the 3rd plus x to the 1st and 2 to the 4th plus x to the 0 and 2 to the 5th, and then you put these coefficients in here like this. So the coefficients would be 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5.
oh, okay.
So what you did, if you imagine trying to multiply this out, you'd have to like keep multiplying x plus 2 and keep doing it. But the binomial expansion gives you a shortcut. And then look at right here, it's all of those numbers are right there. So you just put 1 here, you put 1 here, 5 here, 10 here, 10 here, 5 here, and 1 here. And then you just multiply these things out. So it's just x to the 5th So this equals x to the fifth plus 5, right? Because that's 5 times 2, which is 10. 10x to the fourth. See what I'm doing?
Yeah.
Plus 4 times 10, which is 40. 40x cubed plus 5 to the third is this one, 10 also, and then 2 to the third is 8, so this is 80 plus 80x squared. This is 5 times 4, 2 to the fourth is 16. 16 times 5 is 80 again, plus 80x to the first, plus this is just 32 times 1, so 32.
Oh, wow.
So what you do is that allows you to expand this out without actually multiplying x plus 2 out 5 times
Yeah.
using Pascal's triangle.
With the triangle, how like would you know how many rows to go down by? Like, how do
So
you
it
know?
would be this number, whatever that number is, that's what you want that first number to be.
Oh, okay.
So if you wanted 7, choose 3. It might take you a minute, but you just can write out Pascal's triangle to the 7th row.
Yeah. Okay, that makes
Well,
sense.
technically it's the 8th row because this is the first row, that's the second row, that's the third row,
Okay.
right? Or we can call this the 0th row, and the first row and the second row and the third row and fourth, fifth, sixth, seventh.
Okay.
But it's really nice for binomial expansion because then, because what you're going to do at some point is they're going to say, hey, what's the squared term for this binomial expansion? And you don't have to write all of this stuff out. They just want you to find this term right here.
Oh, okay.
And that's where you just use that formula that I just showed you. But if the Pascal's triangle also helps you because you can just, like I said, you can just take that and write them out and boom, 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 boom. So anyway.
So like that would be like on the SAT maybe.
It could be. Yeah, that could be on the SAT. I think it's coming up in your class though. I don't know what they teach at your school, but it's definitely something that they would have in the honors track.
Oh, okay.
I think it's honors algebra 2 trig and maybe pre-calc both. I'm not sure, but it's something that you will probably see, and definitely probability stats wise. This
Yeah.
is a really important concept to understand.
Okay.
Combinations and permutations is something that you'll get to at some point,
Oh, okay.
but maybe not yet. If you say you haven't seen it yet, it's probably not part of this unit, so it's good.
Yeah, would that be like would that be like a pre-calc thing maybe?
Well, it's a probability concept,
Yeah.
but this isn't a probability concept so much. This is more of an algebra. It's like an advanced algebra concept.
Yeah.
It probably could be an algebra 2 trig or pre-calc. They're kind of like overlap a lot. I don't remember where it is in our district, but
Okay.
I wouldn't be surprised if you saw that coming
Okay.
up this year still. So just be aware of it. It's not too hard, but it's a lot of times they don't show you that. They just have you use your calculator. But I always like to show Pascal's triangle because it's easier even than your calculator.
Yeah.
You don't have to punch all of that stuff in. You can just look at that row and then just put the numbers there.
Yeah.
You know what I'm saying?
Uh-huh.
All right. Well, hey, good luck.
Thank you.
Hope you do well.